Okay, so in section 6.1, this is where we learned about the bisectors. We learned about a perpendicular bisector and an angle bisector. So for the first two questions in this warm-up, what you needed to do is recognize that both of these were perpendicular bisectors. And the way that I can tell that this is a perpendicular bisector is because of the right angle here and the congruency marks on segment AC here. So AC was bisected by the perpendicular bisector, and then I learned the perpendicular bisector theorem that any point on that perpendicular bisector, so for example, point B here, is going to be equidistant from the endpoints of the segment that was bisected. So I can see that AB is going to be congruent to BC. And that's how I'm going to find the value of X, and then I need to plug it back in. So I'm going to be setting 4X minus 7 equal to 3X plus 1. I'll go ahead and subtract the 3X, and I get X minus 7 equals 1. Add the 7, and I get X equals 8. Now, it didn't ask for X, so be very careful on the test to read what it's asking for. It wanted AB, and remember AB was the 3X plus 1. So I'm going to take my 8, plug it in, and do 3 times 8, and then add 1. So the length of AB is 25. So read the questions carefully to see exactly what it's asking for. Then for number 2, same thing. It's a perpendicular bisector. And again, the way that I can tell that it's a perpendicular bisector is because of the right angle and the congruency marks here. So again, any point on that perpendicular bisector, so for example, point B, will be equidistant from the endpoints of the segment that was bisected. So I'm going to set 7X equal to the 5X plus 7. Subtract the 5X. 2X equals 7. Fractions are fair game tomorrow, so be ready to work with them. So then I get X is equal to 7 over 2, but same thing that it was asking for in number 1, I'm also asking for in number 2. I want to find the length of AB, and AB was 7X, so I'm going to plug in 7 over 2 for my X, multiply that, and AB is equal to 49 over 2. If it is a free response question, this would be an acceptable answer. However, let's say it's a multiple choice question, also be able to represent this answer as a mixed number or as a decimal. So be able to recognize all 3 forms of this answer depending if it's multiple choice or not. So all 3 would be acceptable answers if it's free response. Everybody good? All right. The other thing we learned in 6.1 were angle bisectors. So when you have an angle that is bisected, we know that any point on that angle bisector is going to be equidistant from the sides. So I can tell that this angle was bisected because of the equidistant sides here, or distances. And remember, a distance is always perpendicular, so that's why there's right angles there. So in order to find the value of X, I'm going to set 4X minus 8 equal to the 3X plus 4. All right, minus 8 equals 3X plus 4. And then now I'm going to subtract the 3X. X minus 8 equals 4. Add the 8, and X equals 12. This time this question said just find X. But let me add some letters here, because this messed some people up on the quiz. So for example, if I told you that this point right here was A, and this is B, and this is C, and let's say this point right here is D, remember, if I'm asking for angle ABD, I'm looking for this angle right here. And all I would have plugged it into was the 3X plus 4. But let's say instead it had asked for angle ABC. So if I ask for ABC, then I'm looking for the whole thing. So I would have found both of them and then added them together. But again, remember, soon as you found this one, the other one should be the same measure because it was bisected. So be careful. ABC is the whole thing. ABD is just half of it. Or I could have also asked for angle CBD, which would have been this one right here. So just be careful. All right, then the other one that was here, notice how I indicated here that this angle right here is a right angle. So that's what you had to do on number 4, is recognize that this angle right here, where this equidistant segment is meeting, is a right angle. Because again, distances are always perpendicular. So to solve this, you would have done 4x plus 10 is equal to 90. Subtract 10. 4x equals 80. Divide by 4, and x equals 20. And again, that's all they asked for. So for 6.2, it says, in this diagram, the perpendicular bisectors of triangle ABC meet at point G. So let me go ahead and highlight the perpendicular bisectors for you. They're going to be all of these segments. Now remember, the perpendicular bisectors, they are always at the midpoint on the sides. So points D, E, and F here, they're all midpoints. And the point G, where they all meet, is called the circumcenter. We then learned the perpendicular bisector. We learned the theorem for the circumcenter. And that told us that from that circumcenter, I can draw equidistant segments to each of the vertices. So from this circumcenter, point G, I can draw equidistant segments to each of the vertices. So that tells me that segment GB here is going to be congruent to GC, which is congruent to AG. So in order to answer the two questions now, EC is going to be over here. It's the side of the triangle. And remember, E is a midpoint. So if this side's 5, then this side's 5. So EC equals 5. And then GC, since it's that equidistant segment to the vertices, GC is going to be 7. Because all of these are 7s. So here is an example, and it's telling us that all of these in this picture are angle bisectors. So let me highlight the angle bisectors. So the angle bisectors I'm going to do all in red. So they are going to be the ones that go into the vertices. And they're bisecting the angles. And then the point where all these angle bisectors meet is called the incenter. And we learned that incenter theorem that stated from this point of concurrency, the incenter, I can draw equidistant segments to each of the sides. And I can tell that these are all distances because of the right angle. Now don't be confused and think these are perpendicular bisectors. They're not hitting at the midpoint. So these are actually just equidistant segments. So in the problem, they're telling me that AD here is 10. So then that also tells me that DB will be 10, and so will be CD. So DB is 10, because from that incenter, I can draw equidistant segments to each of the sides. In 6.3, we learned about the centroid, and we learned that the centroid is going to be the point of concurrency of the medians. And when we look at these medians, the portion that goes from The vertex to the centroid, these are all the 2/3 portions. So all the blue one is going to be 2/3 the length of the entire median. And then from the centroid to the side, these are going to be the 1/3 portions. So we're going to be working with these as fractions. Do not try to make them decimals. You will not get the correct answer. So for the first question, we're looking at the segment BG. And they're telling me BG here has a length of 9. And they want me to find the length of the entire median, BF. So I know that 2/3 of BF is going to equal BG. I'm going to go ahead and when I do this, I'm going to just put an X here for BF so it's easier to see. So 2/3 of X is equal to 9. And now I need to solve for X. So now essentially what I'm doing here is I'm dividing both sides by 2/3. So to get my value of X, the problem that I'm doing is 9/1 divided by 2/3. And when you divide fractions, you're doing keep, change, flip. So 9/1 times 3/2 gives you 27/2. So the length of BG is either going to be 27/2. If you make it a mixed number, it's 13.5. If you make it a decimal, 13.5. I would accept all 3 of these as an answer for a free response question. Now, if you don't like to do and show this work of the divide by, what I like to do is I like to, once I set it up, my 2/3 X equals 9. Soon as I see that I'm multiplying a fraction by a variable, I know I'm dividing, so I immediately write the reciprocal of that fraction on both sides. Because then this simplifies, these all become 1s, and then I'm just left with X, and then now I'm just multiplying this side. 9 times 3, 2 times 1. You can show the work either way. Now, for the next one, BD and AD, remember the centroid is the point of concurrency of the medians, and the medians are hitting the midpoints of the sides. So in this picture, points D, E, and F, these are all midpoints. So for number 2 here, since they've given me the length of BD and told me that this is 12, and D is a midpoint, so if this side's 12, so is AD. So the length of AD is 12. And then for CD and finding GC, CD is this whole median here, and it equals 27. GC is the 2/3 part. So what I'm going to do here to solve for it, I'm going to be doing 2/3 of CD is equal to GC. And CD is what was given to me, so 2/3 times 27/1 is going to give me the length of GC. I like to simplify diagonally, so I'm going to go ahead and change my 3 and 27, change this to a 1, change this to a 9, and then 2 times 9 is 18, and 1 times 1 is 1. So the length of GC is 18. Now, when you're doing questions like this, make sure your answers are making sense. Okay, if they've given you the length of the whole thing and you're trying to find a little piece, obviously the number is going to be smaller than what they've given you. Or if they give you a little piece and you're looking for the whole thing, then your answer should be bigger. So just make sure that these numbers are making sense after you do the calculations. So also be able to find the coordinates for the centroid, and it'll be any type of triangle. So technically what we're supposed to do is find the midpoint of all three sides and then draw in each median. So from the midpoint to the vertex creates a median, and then you're looking for the point of intersection. However, I'm going to show you a shortcut. And the shortcut is just to find the average of the x's and the average of the y's. And I'm going to show you both ways. I'm going to show you the long way, just in case you're ever asked to draw in the medians and find that point of concurrency. So first thing I need to do is find all the order pairs. Now on the test, I'm not going to give you the triangle already graphed. I'm just going to list the coordinates. I give you a blank coordinate plane if you choose to graph it. The questions that involve graphing, the graph is provided, but I'm not grading the graph. It's only there for you to do your scratch work. So let's go ahead and figure out what A, B, and C are. So the order pair for A is -3, +1. The order pair for B is 1, 5. The order pair for C is 5, -3. Now, the way that you should be solving this without using the trick is to first find the midpoint of AB. So I'm going to go ahead and add my x's and divide by 2. And I get -2/2, 6/2, which gives me the order pair 1, 3. So I'm going to go ahead and graph -1, +3. This is the midpoint of AB. I will draw in the segment from the vertex to the midpoint, and that's a median. Next, I'll find the midpoint of BC. So I'm going to add the x's, divide by 2, add the y's, divide by 2, and the midpoint of BC is 3, 1. So I'll come over here and I'll graph the order pair, +3, +1, and then draw in the median to the vertice. Next, I need to find the midpoint of AC. -3 + 5 divide by 2, 1 + -3 divide by 2, 2/2, -2/2, 1, -1. So I'll plot that median, and then I'll draw that midpoint and then draw in the median. And now I'm looking for the point of concurrency where all three medians intersect, and that is going to be the point 1, 1. So this is the appropriate way to do it. However, on the test, you can use the shortcut. I give you the graph if you want to confirm your calculation, but you don't need to do this. However, if you see this on an SAT or a PSAT, this would be how you would draw in medians. So the shortcut is to take each one of the x's, so -3, +1, +5, divide by 3, take each of the y's, add them, divide by 3. I get 3/3 and 3/3, and notice it simplifies to 1, 1, which is exactly the same centroid I calculated by drawing in each of the medians. The problem with actually drawing the medians, if your centroid actually is a fraction, let's say it was 1.5 or 1 2/3, if your graph doesn't go in fractional increments, it might be hard to find. So this is where the trick pays off. So add the x's, divide by 3, and add the y's, divide by 3. So for number 5, what type of triangle has its orthocenter on the triangle? And this would be a right triangle. Know where all of these points of concurrency are located on any type of triangle. So for the mid-segment, here what we're doing is they're giving us the length of UV, and they're telling me UV is 13, and they want me to find the length of RT. Well, we learned that the length of the mid-segment is always half as long as the side of the triangle. So since my mid-segment is 13, all I need to do is double it, and that'll give me the length of the side of the triangle, and it'll be 26. For number 2, this time they're giving me the side of the triangle, and they're telling me that ST is equal to 20. And they want me to find the length of the mid-segment that's parallel to that side. So remember, when they give you the length of the side of the triangle, all I have to do is divide it by 2, and that mid-segment, half of 20, or divide by 2, would be 10. So all we do here is 20 divided by 2, and the length of UW is 10. Now remember, all of these mid-segments are always half as long as the sides of the triangle. So if they give you the perimeter of the entire triangle, all you need to do is divide it by 2 to get the perimeter of the mid-segment triangle. And then for the last one on this slide, they're giving me that the length of VW is the 2x minus 4. And they're giving me the length of RS, the side of the triangle, to be 3x minus 3. So in order to find the length of VW, I know that it's going to take 2 of the mid-segments to equal the green side of the triangle. So in order to do this, I'm going to take 2 times the mid-segment and set it equal to the side of the triangle. I'm going to distribute, combine my like terms, move the 8, and I get x is equal to 5. Didn't say to find x, it wants VW, and remember VW was 2x minus 4, so now plug in 5 for x, multiply and subtract, and VW equals 6. All right, so for 5, it wants us to list the sides or the angles in order from least to greatest. So on the test tomorrow, make sure you read the order. It could say greatest to least on the test. So make sure you read it, because if you put it big to small and it wants small to big, you get it wrong. So in this case, it wants the smallest side first. So I'm going to look for the smallest angle. So my smallest angle is the 50. So this tells me that AB is going to be the smallest side. And then the next biggest angle is the 60. So its side that it's across from, this will be the middle one or the medium size, is going to be BC. And then finally, the largest angle is 70, and it's across from the longest side, which is AC. So that'll be the largest. Now, if they give you sides and they ask you to order angles, we're doing the same thing. So my smallest side is the 25, and it's going to be across from the smallest angle, which is going to be angle R. And then the next biggest side is the 30, and it's across from angle T. So angle T will be the medium size angle. And then lastly, the largest side across from the largest angle, which is going to be angle S. And this is from least to greatest. Now, if you did this and you just put commas in between, let's say you did AB, comma, BC, comma, AC, that's acceptable as well. Same thing with the angles. It didn't ask you to write them as inequalities. Then for number 3, they want to know whether these 3 numbers will form a triangle. So again, I need to find the 2 smaller numbers, so 35 and 18. I'm going to add and subtract them. This gives me 53, and then when I subtract it, I get 17. So now I need to check to see if that biggest side will fit in between here, and it does. 37 is in between 17 and 53, so this answer is yes. Then for the next one, take the 2 smaller numbers, add them, subtract them. We need to see if that last side is in between here. However, it equals this sum, so this one is no. It cannot equal the sum or difference. This one says Jeremy wants to build a triangular toy using sticks, and he wants to know what could be the possible lengths for that third side. So we're doing exactly the same thing. Add 12 and 10, subtract 12 and 10. So then my 2 sides, or the range, will be any number in between 2 and 22. Be able to write it as a compound inequality just like this. And then the last 2, all we're doing is filling in a greater than, a less than, or an equal to. So here, they want us to compare this side here, KL, with NP. Everybody good? Anybody need me to go back to anything? Okay, so use the warm-ups, use your reviews, your notes, your homework, all of your stuff. And again, 20 questions tomorrow, but half of them are multiple choice, no proofs. Pretty good? And talking to the earlier classes isn't going to help you as far as the sometimes, always, or never, because I wrote enough of them where every class gets different sometimes, always, or nevers. So talking to them isn't going to help you. Just know your stuff. Everybody gets different. Anybody need me to go back to anything?